Welcome to the Approach to ABGs Part 5, osis versus emia. We're going to cover normal ABG values, and then we're going to define what is an osis and what is emia. So the normal values for bicarb, which is the metabolic component of the ABG, a normal bicarb is 24, and a normal CO2, the respiratory component, is 40. So you need to memorize those values. When a ABG is written down, it's usually written with the pH and then a slash, the PCO2, the PO2, which we're going to ignore for now, and the bicarb. Remember, the PCO2 is respiratory, the bicarb is metabolic, and the normal values, which you've seen all of these before, pH 7.40, PCO2 40, and a bicarb of 24. You must memorize these three values because when you do an analysis of an ABG, you're going to be comparing the value of the ABG that you have in front of you with these normal values. You're going to have to be able to identify, is this value increased or decreased? So what is an osis? An osis is when you have any change in either the PCO2 or the bicarb. And it is possible to have more than one osis process at the same time. For example, both the PCO2 and the bicarb could be elevated, or both of them could be reduced. But just to get you started, the first few examples we're going to look at are just going to have one osis process. So again, bicarb is metabolic, CO2 is respiratory, and when you have a metabolic acidosis, you're going to have a low bicarb. A metabolic alkalosis will be a high bicarb. Respiratory acidosis is going to be a high CO2, and a respiratory alkalosis is going to be a low CO2. So let's see if we can put a couple numbers into our equations and see what that looks like. So normal values, bicarb 24, CO2 40. We're going to ignore the hydrogen ion concentration for now because I just want you to focus on identifying the osis. So if we had a bicarb value greater than 24, we would say that there is a metabolic alkalosis process. If we had a bicarb value less than 24, we would say that we have a metabolic acidosis process. And same for carbon dioxide. If we had a carbon dioxide value greater than 40, this will be a respiratory acidosis process, and if it's less than 40, a respiratory alkalosis. When you are determining the osis process, you do not need to look at the pH. You're only looking at the PCO2 or the bicarb. And you can have both a metabolic and a respiratory osis at the same time. And the reason why we're not going to look at the pH right away is because if you have a metabolic process that is the opposite to the respiratory process, if you had a metabolic acidosis and a respiratory alkalosis, they could cancel each other out and give you a normal pH. So I don't want you to be confused if you look at the pH and you see that it's normal. I don't want you to assume that everything else is normal. So we're always going to start looking at the osis process first. Emia means in the blood, and the pH defines the emia, since the B in ABG means blood. So we're doing an arterial blood gas sample. We've literally taken blood and we're analyzing it. And so the pH, if it's low, is going to tell us that we have an acidemia, or if the pH is high, will tell us that we have an alkalemia. So the pH tells us the emia, while the bicarb and the CO2 are going to tell us the osis. And a very important rule, you need to determine the osis before you determine the emia. So you're going to analyze the bicarb and the CO2 before you analyze the pH. So let's go into a couple numerical examples, and we're going to use the osis process to predict the emia. So if I told you that the CO2 was 50, you would look at that and you would say, okay, the CO2 is higher than normal. What is this going to do to the hydrogen ion concentration? And we're going to go back to shifting chemistry. So we have a high value of CO2. This is going to shift the equation to the left. This is going to increase hydrogen ions. The hydrogen ion concentration going up is going to reduce the pH. So we would predict this is a respiratory acidosis causing acidemia. If we had a CO2 that was low, for example, a CO2 of 27 is 13 points lower than normal, this is going to create a little bit of a vacuum on the right side of the equation. So the equation is going to shift to the right. This is going to consume hydrogen ions, which is going to reduce the hydrogen ion concentration. And as a consequence, we're going to have a higher pH. So this is a respiratory alkalosis causing an alkalemia. If we had a bicarb of 17, this is a low value. It's going to cause a little bit of a vacuum on the left-hand side. It's going to cause a shift in the equation, to the left, and this is going to increase the hydrogen ion concentration. It's going to drop the pH. So here we have a metabolic acidosis causing an acidemia. And if the bicarb is increased, here it's a value of 30, which is an increase by 6. It's going to push the equation to the right with the shifting chemistry. This is going to consume hydrogen ions, and so you're going to have an increased pH. This is an example of a metabolic alkalosis causing an alkalemia. So remember, you're always going to determine the osis before you determine the emia. And this is going to be very important when you have more than one osis. So I want you to get in the habit of doing the osis first and then look at the emia.